Hi everyone, myself Satyajit Paul. Today, we are going to begin an exciting journey into a concept that forms the very foundation of calculus, modern mathematics, which is limits. Let's start with a simple idea. Okay, imagine you are walking towards a wall. With every step, you cover the remaining distance to the wall. Okay, with every step, you cover half the remaining distance to the wall. At first, you move quickly, covering larger distance, obviously. But as you get closer, your step becomes smaller and smaller. Right? Now, here is a question. Will you ever actually touch the wall? Think about it. And your hint is you're always covering half the remaining distances. Okay? The idea of approaching something, getting infinitely close to a value without necessarily reaching it, is the essence of what we call a limit. So, what is the definition of limit? The idea of approaching something, getting infinitely close to a value without necessarily reaching it. Okay, so that means if okay, we will learn it in different slides. So basically, in this lecture, we will cover the definition of limit, what we have discussed already, and we will discuss that how we can calculate the limits and what is the significance of limit. But before going deep into limit, we at first need to understand the basic of function. What function is. So basically a function is a rule that maps a number to another unique number. Function is a rule that maps a number to another unique number. But sir, you will say that sir, this is very hard to understand or hard to type this. So let's understand with an example. Suppose we have a example over here. Okay, so you can see that we have a function which is f of x equals to 3. Sorry, f of x equals to x plus 3. So from here we can say that suppose we put x equals to 1. So for x equals to 1, what will be the value of fx? Can you please tell me? 1 plus 3, which would be, give me 4. If x equals to 2, it will give me 5. Then also in x equals to 3, it will give me some another value. So basically, there is a domain you can say that which is 1, 2 and all, and which is, this is the f of x, and this something we called as a 4 and a 5. So basically 1 is mapped with 4 and 2 is mapped with 5. So this is called the function. How uh, dependent variable is, and this is called function, and the x over this function, which is which we are providing, like we are saying that if x equals to 1, if x equals to 2, so this is a independent variable. It is not dependent to any of other variable, just like f of x, right? F of x is dependent on x, right? If we give x equals to 1, then it will give me some value. If I give x equals to 2, then it will give me some another value. So it is not a constant value, or we can say this is a dependent variable. Okay, so now how we can plot a graph. So we have considered that the function here is x equals to 3x square minus 4. So at different point we put some values of x, right? Like x equals to 0, x equals to 1, x equals to 2, and x equals to minus 1 and also minus 2. And we calculate the functional value, means the value of y. We can write that f of x equals to y. And we've plotted it in a graph. Like at x equals to 1, we got functional value is minus 1. So that is how we can plot the points and then we join the points. And that's how we can get a graph of a function. Now let's handle some typical problem. Suppose you have a problem like this, that f of x equals to x square minus 4 by x minus 2. Clearly it is visible that if we put x equals to 2, right? If we put x equals to 2, then what will happen? 2 square is 4. 4 minus 4 by 2 minus 2. Something divided by 0 which is undefined. Something divided by 0 in mathematics is called undefined. So this undefined. So at x equals to 0, there is no functional value. This is the meaning of this. And how we can represent it? Suppose uh, we represent as a hollow circle. At x equals to 2, there is no value, right? But if we go farther, like if we go near it to the 2, just near to the right or just near to the left, like just near to the right will be 2.00001, and just nearer to the left will be 1.9999, and there we can have the value of the function. Because 1.99999 minus 2 will not equals to 0. 0 4 point not 1 minus 2, it will not result the value of 0. So we can have some definite value of that function, right? So this is the concept of limit. Basically we are not finding the value of a particular point. We are not finding a value of a particular point just in case x equals to 2, but we are finding the value of nearer to the value. Like if we want to find the value of f of x at x equals to 2, we cannot find, but we can find the value nearer to the 2, nearer x equals to 2, which is uh, basically some part of x, right and left side, that is the case. Okay. So here we have the concept of left hand limit and right hand limit. Left hand limit is that in suppose at x equals to 2, we are approaching x equals to 2 from the left. Okay, we are approaching x equals to 2 from the left. Then this is called the left hand limit. We can write limit x tends to 2 minus why 2 minus, because we are approaching behind the 2. Okay, f of x. Then we can find the value of limit x tends to 2 minus, which is just nearer to the 2. It will give me a almost approximate value of 4, right? And similarly, if we approach at the same point from the right hand side, we approach the same point from the right hand side, then what we will get? Then we will get the similar kind of value, which is 4. And how we can write this? Limit x tends to plus f of x. Understood? Then we will graphically understand what is the meaning of left hand limit and right hand limit. Suppose there is a graph which is discontinuous at the point. We don't need to understand what discontinuity means, because it is the basically meaning of the the graph is broken. In here, the graph is broken, right? And we have to find the limit of at x equals to a. So definitely we cannot find the value at x equals to a. So we can find the limit of that function, right? Limit means we are not particularly evaluating the value at x equals to a but nearer to the a. Okay, suppose we are approaching toward from the left, we are approaching. Okay, uh, suppose we are approaching the limit toward from the left hand side. So left hand side, we can write that if the approaching value is very less, like a plus h, so we can write from here it is a minus h, right? A minus h we can write. So so this is how we can define a limit, that limit h tends to 0 f of a minus h, where h tends to 0. So if we put the value of h tends to 0, then it will becomes the f of a. So we are getting the value, getting the same value. So here how we can mathematically formulate left hand limit and right hand limit. Okay. So here is an example where x is the greatest integer or box function. We know that in from the knowledge of our algebra. So suppose we are applying the basic formula, which is this. So we have to find the right hand limit of x tends to 3 for this limit. So we just put x in place of a plus h. We are replacing x with a plus h. So if we replace it, then it will the box x will becomes 3 plus h minus 3 by 3 plus h minus 3. So this will cancel it out, and we know that and h is something value which is greater than 0, very very near it to the 0. So we know that from the definition of box x, that if box x is uh, box x equals to x when x box x equals to 1 when x is 0 to 1. So here it is almost 3.000 something, so it will return the value of 3 on. So that is here we have write that 3 minus 3 by h, which is 0 by h, which is 0. Okay, so existence of limit, how we can say that some limit is existing or not. For that, we need to check the left hand limit and the right hand limit, and if the value of the both limit becomes equal, which is equals to L, then we can say that the limit does exist. Or okay, let's have an example. Look at the example of this. F of x equals to 1 plus x square, where x is been in between 0 to 1, and 2 minus x, where x is greater than 1. So we have to find the right hand limit and left hand limit at x equals to 1. So how we can find? So if we suppose that we have to find this thing, right? So we can write h tends to 0, and in place of x we can write 1 plus h, but we are approaching from the what, from the right hand of the x, so which is greater than 1. So we have to take this function, right? So which give me the value of 1. And if we are approaching left hand side from this function, so we have to consider this value, because this is the value where the x lies between 0 to 1. Suppose we are approaching like 0.99999, so in which region it will fall? In this region, obviously 0x1. So we have this value. So suppose 1 plus 1 minus h square. So we are just putting x in place of 1 minus h. And we for LHL put x equals to 1 minus h. And for RHL, we have to put x equals to 1 minus h, or a minus h, we can write a plus h. That is the key concept. Okay. Now, let's see some example, right? Suppose we are getting some value which is 0 by 0. In mathematics, it is undefined, but we have to find the limit, right? We have to find the limit. So that is why the limit is very much important for mathematics, in mathematics. So what is the methods? So at first we will learn about the indeterminate form, like 0 by 0, infinite by infinite, infinity minus infinity, 0 to the power infinity, 0 to the power 0, and infinity to the power 0, and 1 to the power infinity. These are 7 indeterminate form, and we have to solve the limits differently. Okay, let's have a look on the 0 by 0 form. So 0 by 0 form, we can basically just factorization method. Okay, suppose we have a problem, we will understand by problem only. We have a problem, and looking into it, it can be factorized into x minus 2 and this part, and it is also being factorized into x minus 2 and x minus 1. Now from the both end, x minus 2 will get cancelled out, and it will eventually gives a value of 10. Okay. At first, at x equals to 2, if you put x equals to 10 2, then it will give the value of 0 by 0. But we have cancelled out the factor which was causing the 0 part, like x minus 2 part, right? For this, if we put x equals to 2, then it will become 0. So eventually this factor is causing the 0 value. Okay, so this is how we can factorize and calculate the limit. Then suppose we have a square, numerator or denominator, or both involve square. Then we have to do rationalization. This is also a very easy method. So what you have to do this, like if we have a square root involves in numerator, then we have to just multiply it with its conjugate in numerator and denominator. So what is the conjugate of this function? This function, it will be just negative to positive, right? So it will becomes my a square minus b square, right? And a square plus b square, a minus b into a plus b. So it will eventually give me a square minus b square, right? And if we common 3 from that function, then it will eventually gives me x minus 3, and my x minus 3 will be cancelled out. And if you put the value of x equals to 3 in the remaining portion, then it will eventually gives me 3 by 8. Okay. Now, now there is a very interesting rule, the L'Hopital rule. L'Hopital rule is only applicable for 0 by 0 form. Suppose we have any 0 by 0 form, like this also. We can apply it on this also, but we are just looking into this example, sin x by x. So what we can do, differentiate numerator and denominator. That's it. So differentiation of sin x will be cos x, and differentiation of x will be 1. So it will eventually becomes 1, and there is no something by 0, no undefined term. So we can directly put cos of 0, which will gives me 1. Right. Now suppose we have some limit which tends to infinity, limit x tends to infinity of some function. So how we can solve this? So to solve this function, we just have to common the greatest term or biggest term in the numerator and the denominator. We have to common it. So in the numerator, what is the greatest term? X to the power 3, right? So we common the x to the power 3, and remaining term we just write it out. And in denominator, what is the greatest term? X to the power 3. Here also we common it up and write the remaining term. So in there, if we closely observe, it will give me a 3 by x and 1 by x cube. Now if we put x equals to infinity as 3 by x, so 3 by infinity, which would be given me the value of 0, right? So eventually this part will become 0, and the limiting value of this will be, this part will also be cancelled out, and the limiting value would be 2 by 4, which is 1 by 2. So that is all. As we conclude our discussion on limits, let's reflect what we have learned. Right? Limits are fundamental concept in maths that allow to understand how function behaves as they approach specific point or even infinity. Okay. Remember, limits are not just abstract thing. They are everywhere in science. Even when you deep dive into calculus, you will find that limit are foundation for derivatives, integration, and many more. Okay, so keep practicing. Good work, everyone. Thank you.